The EchoShore-TX technology is an extension of one of Echologic's core capabilities, where we've become a world leader in detection of leaks in large diameter pipes, finding hundreds of them around the world. And now it allows us to monitor critical pipelines on a permanent basis. A leak in a large diameter pipe can often be a warning signal of an impending failure. These pipes don't leak very often, but when they do, the water can go into the soil, destabilize that soil, cause stresses on the pipe. So finding these leaks very early when they're very, very small allows us to mitigate the risk of that type of failure. The EchoShore-TX has two major value propositions for a utility. The first is in finding leaks, finding them early, and reducing the water loss. The second is really in the proactive asset management of your water infrastructure. So EchoShore-TX can increase the life of a pipe and increase the reliability for both the utility and its customers. So when we imagined monitoring water pipelines for leakage, it was only natural that we thought about a number of other parameters, because when we design the electronics, we can accept virtually any sensor that's 4 to 20 milliamps. So we can monitor pressure, we can monitor temperature, we can monitor water quality, we can monitor flow, and we can do it in a way that's very different from conventional technologies, because you can have this data anytime you want. It doesn't count on the device waking up at 8 a.m. and sending the data to you. You can wake it up anytime you want, which provides a lot more value to that data. If a pump goes down, what's happened to my pressures all over my system? What's happened to my flow? Did it cause any leaks? We can get that information to you instantly. So the EchoShore-TX system is different from other transmission main monitoring systems in a couple of different ways. The first is that it's the extension of a proven technology where we found hundreds of leaks on pipes up to literally 108 inches or about 3 meters in diameter. The second way is that we have developed a correlation technology that's very accurate and very precise. Many of the other technologies use multi-parameters to try and tell them what's going on in the pipe. Has the flow changed? Has the pressure changed? Is there a pressure transient that's been generated by the formation of the leak? We cut through that and we just say, is there a leak there? And we correlate that leak and tell you exactly where it is. So situations where a utility would derive the greatest benefit for this type of technology are numerous, but I can think of two of them that are obvious. And one is that you've got a pipeline that runs through your downtown core, and if it fails, then the city is in trouble. Traffic, damage to other infrastructure is inevitable. The other real compelling use of this technology would be an extension of infrastructure asset life. So if you have a major pipeline that's very difficult and very expensive to replace, you can extend the life of that pipeline by putting this technology on it and mitigating the risk of failure of that pipeline.